So now we're going to be looking at the 2022 paper, question 6, paper 1 for the higher level maths exam. So it says, part A, the function f is defined as follows for x being an element of R. F is a mapping which sends x to the function x cubed minus 6x squared plus 3. Use calculus to find the coordinates of each of the following points. So 1 and 2 involve finding the local max and the local minimum point of f, and part 3 asks for the point of inflection of f. So let's just look at the first one, or parts 1 and 2. Whenever you're finding the local max mins or the point of inflection, what we're going to be doing is just solving a derivative of the function, whether it's the first or second derivative, equal to x, and whatever value we get, we stick it back into the original function, and then we're going to get y. So if we write this out again, we're going to have f of x is equal to x cubed minus 6x squared plus 3. So we find the derivative of this, f of x is going to be 3x squared minus 12x. That 3 is a constant, so we get rid of it. Or it just equals to 0, so we don't have to write it in the second one. So we can simplify this by factorising out 3x from both terms, and then we're just left with x minus 4 in the middle. So we have 3x equaling 0, so x has to be equal to 0. And then we have x minus 4 is equal to 0, so then we just have x is equal to 4. As I said before, these 2 points we're just going to sub back into the original function, and they're going to give us the local max or the local min, and then we just have to figure out which is which. So if we find f of 0, that equals 3, so it gives us the point 0, 3. And then if we find f of 4, it gives us negative 29. So that's 4 minus 29. I'm not showing you doing these calculations because it's just sticking it into your calculator. So now we just need to figure out which one is which. Looking at this original function, what we have is positive x, so we know that it's going to have this sort of a shape, where that tails off and that tails off. So if we know that's going to be the fact and that it goes up, down, and then back up in some sort of way, and we plot this, we know that this point right here has to be 0, 3, and then this point right here, because it's further along, is 4 and negative 29. And in reality, our axes will go something like that. So we know that this first one is going to be the local max, and then the second one is the local min. And what I've done below is use GeoGebra just to graph this out. So if you type in that function, this is what it gives you. And we can see at the very top, although it's not written, this point right here is 3. So that gives us the point 0, 3, which is the max. And then if we go all the way down, we have this bottom point here, which is when x was equal to 4, which gave us negative 29. So we know the local minimum is going to be 4 minus 29, and the max is going to be 0, 3. Now we're going to be solving the point of inflection. How do we do that? Well, point of inflections are when it change from concave up to concave down. And how do we know, or how are we going to be able to find it? Well, where this would change from concave up to concave down is where we're going to change from this sort of a shape to this sort of a shape, as you can see here. The question doesn't ask which one's which, we just need to find the point in which it occurs. And how do we do that? Well, if we find the second derivative of the function and equal to 0, we're going to be able to solve it. So f double prime of x is equal to the derivative of f of x. So we're going to be looking back up and figuring out what this is. So 3x squared minus 12x, that's just going to go to 6x minus 12. Equal that to 0. And solve for x. We get x is equal to 2. Same as we did in the first step, we're just going to be finding f of 2 then. And if we figure out what that is, we're going to end up with the point minus 13, i.e. 2 minus 13. So the point of inflection is going to be 2 and minus 13. So if we look at the graph and we go to 2, down to minus 13, right here. So it's right on the graph, so we know it's going to be there. So it's at this point that if we just use a highlighter to distinguish the two, the function will go up and down. And at this point right here, if we change to yellow, it changes from going to down to up. Going on to part B. The diagram below shows the graph of the cubic function g of x for some value of x between negative 2 and 2.5, where x is a real number. There's a local minimum point at minus 1 and 2, and a local maximum point at 1, 6. Write down the values, or the range of values of x for which g of x is increasing. If it's increasing, it means it's going upwards when we read it from left to right. So it also gives the minimum points. So we know this right here is a minimum, and then we know this right here is going to be a maximum point. So quick way of doing this, if we just divide it along the turning points, we can see that to the very left hand side, this is going down. In the middle, this is going up, and the right hand side, that's going down. So where does this occur? Between -1 and +1. So we know that x is strictly less than or greater than 1, but it's strictly greater than or equal to -1. Explain why the function does not have an inverse for a value of x between -2 and 2.5. To find the inverse of a function, we can't have multiple values of x mapping to the same value of y, to put it simply in terms of this graph. So if we look at this graph, you can kind of use a straight line test. If at any stage we're able to move this straight line up and it contacts in more than one place, we can say that it's going to not be able to find the inverse of it. So if we look right here, we have the red line crossing at this point here, and all the way at this point here. So because it crossed the 3 separate points, it can't have an inverse. So we want to explain why. We can say that the y being equal to 3 has 3 x inputs. In other words, if we subbed in f of minus 1.5, this looks like it would be maybe minus 0.66, and then all the way over here we have call that 1.8. If we sub those 3 values into f of x, we'd get 3. So we have 3 values being mapped to by the same value of x. So that's why it can't